Welcome to today's DevOps.com workshop, brought to you by Techstrong, AWS, and HashiCorp. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting workshop ahead, but first I have just a couple of housekeeping notes to cover. Today's workshop is being recorded, so if you miss any of it, or you'd like to maybe pick up later where you left off, this workshop is meant to be more of a follow along, and with the on-demand being available shortly after this concludes, feel free to follow along with this workshop again and again. If you have any questions for Mike today, we want you to submit those using the comments tab or the Q&A. We will be monitoring both. We will also be giving away 4 $25 Amazon gift cards, so be sure to stick around till the very end of today's workshop. So the topic today is Modernization Workshop with HashiCorp and Terraform Cloud. And I'm joined today by Mike Thorpe, Senior Solutions Engineer at HashiCorp. Mike, thank you so much for being here with us. And I know we have a support staff of others to help, but to our team helping out today, thank you so much. Let's go ahead and get this show on the road.
Awesome. Thank you, Cody. Well, like Cody said, my name is Michael Tharp. I'm a Senior Solution Engineer here at HashiCorp. And before HashiCorp, I was a practitioner for over 20 years. So I guess we'll just go ahead and jump right in. We're going to be covering Terraform Cloud today. So we actually did a webinar a couple weeks ago talking kind of about the differences of getting Terraform into production, going from open source to taking Terraform to actual production. So it might be interesting if you want a little bit more of a deep dive into that to kind of just start there. But what I wanted to talk about today is infrastructure as code, and kind of talk about why that's important, just as a quick follow-on to that. So obviously, when we start talking about things like infrastructure as code, it's important to understand that infrastructure as code gives us a lot of capabilities, and those capabilities as far as being able to do things like documentation as code, and really allowing us to move to the cloud much quicker, right? So we have this ability to be able to take our code, define it as far as our infrastructure, and then deploy that. So that becomes really easy when we start to talk about the adoption of cloud and kind of moving to this cloud model, because it doesn't really matter where it lives. We're going to change some syntax around and we'll be able to deploy to the cloud. So that's really what we're here to talk about. And it really is about using Terraform to provide that infrastructure as code baseline, as well as including compliance and management and some of the enterprise features that you need in order to take Terraform into production. So a lot of collaboration, a lot of cloud compliance, and obviously self-service along the way as we start to scale up. So that's just kind of the overview of what we're talking about today. And in doing that, I want to talk about the few challenges that we have as far as infrastructure and provisioning is concerned. So if we're on-prem today or we're looking at hybrid cloud, we kind of know what those challenges are. People, processes, and tools are kind of the 3 key areas that we start to look at when we start to struggle with the provisioning of infrastructure, right? Whether it's onboarding something new, very manual workflows or different workflows. So we say, hey, we do this on-prem this way, but then we do this in the cloud this way, and that kind of makes for this kind of ad hoc type of a process where it's very difficult for us to get consistency when we're going from on-prem to in the cloud. As far as processes are concerned, using some sort of ticketing workflow was fine for a long time, but if we need to move very rapidly, we need to be able to be very agile. It becomes very difficult to try to maintain and manage. It doesn't really give people the ability or the empowerment to be able to deploy infrastructure, and then making sure we have the right tools in place. And when we start talking specifically about Terraform, that's really what we want to target when we start talking about infrastructure as code, and specifically taking Terraform into production is that increased productivity, reducing our risk by including things like compliance, and reducing our costs, making sure that we're only deploying the things that we need and we're not over provisioning and idle resources and orphaned resources. So I'm not really going to cover who is HashiCorp, right? We are automation company, if you're not familiar, but kind of want to talk about the workshop prerequisites, because I think this is really important. So as far as the workshop prerequisites, we are going to add an AWS account. Are we going to need an AWS account? But we're going to add some users to that, and we'll need to make sure that it has the proper permissions. If you don't have an IDE, if you're not using something like VS Code or Atom, and you need to be able to edit your code, you can use Cloud9. I really won't spend a lot of time. It is in the setup guide, so if you want to kind of go through that in detail, you can, but that's available to you. And then what we would like to cover is just a basic understanding of Terraform Cloud and some of the HCL pieces that come along with it. So let's go ahead and get fired up. Is everybody able to see my screen okay? I think we were having a little bit of a delay, and I want to make sure that everybody's able to see the screen okay. If you want to put in the chat, just whether you can see my screen okay. All right. So let's move on. So a little bit about this workshop. This is designed to be a self-paced workshop. So if we're moving along and you get a little bit behind, don't worry about it. It's okay. You can rerun this again and again. If you want to revisit it, so say we make it all the way through and you're good, and then maybe a week later you say, you know what, I'd like to revisit that to make sure I truly understand what's going on, you can do this at any time. So we're going to create an AWS account with the proper permissions. The AWS credits, we actually don't have that available today. That's actually an older piece, but so we'll just assume that you have that AWS account that you're able to use. If not, you can set up one. Like I said, I won't spend a lot of time on the Cloud9 IDE workspace. Like I said, I use VS Code myself. Some folks use Atom, some people use VI. Whatever you want to use for your IDE of choice is fine. We'll create an IAM role. We'll attach that IAM role, and then we can finish configuring the Cloud9 workspace. So we'll start with something really basic. We'll set up that AWS account. So we're going to start by logging into our AWS account that we have and creating a user. Pretty basic. You've probably all done it before, but we're going to create that user. You can call it whatever you want. In this example, we have workshop. Right? We want to make sure that we have the AWS Management Console access enabled. We also want to make sure that we don't have this checked, right, which is a required password reset. Otherwise, it's going to send an email and ask you for a password reset. And then we'll go ahead and click Next so we can set our permissions. From here, and this is all traditional AWS configuration, we're actually going to attach an existing policy. We want to use administrator access. Really, the reason why we're doing this is so that we don't get blocked by any specific permissions and trying to assign a bunch of different granular permissions. So we'll actually do this administrator access. Once we do that, we'll go ahead and click Next to review. And what you want to do is you want to make sure that your screen looks similar to this, right, where you have a username, you have your access type, your console password type is custom, require password reset is no, and the permission boundary is set is not set. So we just want to make sure that, and also make sure that your permission summary is set to administrator access. You'll just click Create User on that. Once you complete that, you'll actually be given a screen that gives you a URL that you can use. You want to keep that URL, and what I like to do is I actually like to download that CSV just so I have that on my machine to give you all the information that you need. And obviously it'll show that the user that you created is available to us. Now, if you are using Cloud9 or you need an IDE and you need to be able to configure that's actually where this is located. So if you look at step number 3, it'll actually walk you through setting up that IDE. So you'll go through all the spin up areas there, walk you through that piece. Then you'll configure it. So you'll actually go into the configuration items. There'll be a few items that you'll need to set there. You'll need to run some commands, and then you'll need to install the Terraform CLI. If you were using the Cloud9 IDE, you'll use Amazon Linux, and you just follow this, verify your installation, and then you'll use Bash if you're using the Cloud9 IDE. Otherwise, if you're doing this on your machine, you can feel free to follow any of those steps for whatever operating system you're using, whether it's Windows, Linux, Mac OS X, whatever you're using. You can just follow those directions. All right. So if everybody's good there, I'm going to go ahead and take a quick pause because we covered kind of that self-guide setup. And depending on how much you need to set up, if you need to do the Cloud9 setup, I want to give you guys a couple minutes to be able to do that. So I'm going to go ahead and take a pause here, and we'll do about 5 minutes. And when you're done, if you could just type done in the chat, that would be great. Absolutely. You can use VS Code as your IDE. That's what I use. Cloud9 is there if you don't already have a IDE environment available to you. So if you're using VS Code or Atom or any other, if you were using Vim, Emacs, whatever you want to use for your IDE of choice. And I'll go ahead and get fired up. It looks like everybody's ready to go, so we'll go ahead and get fired up. So let's talk a little bit about Terraform Cloud. So when we start talking about Terraform, and specifically Terraform Cloud, kind of the differences that we see between open source and Terraform Cloud is the infrastructure as code is the baseline for everything that we're going to do, right? The difference is going to be when we start talking about Terraform Enterprise and Terraform Cloud is that we start to include things like collaboration, deep collaboration, VCS driven workflows. We start to talk about governance and compliance. We start to talk about self-service. And those things are very difficult, if not impossible to do with open source because it's really not designed to be used by anybody other than an individual, right? So Terraform Cloud and Terraform Enterprise really address these specific areas to make sure that we understand how to go about doing that and make it very easy to be able to onboard those types of workflows. So talking specifically about infrastructure as code, right? Infrastructure as code, if you're not familiar, and this, I'll make this quick because probably most everybody here is familiar. Infrastructure as code is really, really valuable as far as configuring our infrastructure for quite a few reasons. One, like I said, Terraform is going to enable this VCS driven workflow. So it's going to make it very easy for us to be able to create new infrastructure, to be able to change new infrastructure, and do that all via code. And when we're kind of looking at this from an infrastructure as code perspective, the one area that I think kind of jumps out right to me when I very first started using infrastructure as code is this idea of documentation as code as well. So as we're building our infrastructure as code, we're actually documenting what our infrastructure is, right? So the need to create runbooks or wikis that are really out of date the second we use them are very difficult to keep and maintain. We have that available to us in our code. We can see what's out there, and we can also roll forward and roll back very, very easily, right? So with HashiCorp configuration language, we make this very easy because it's very human readable. It's very easy to understand what resources you have, what's tied together, and really what's going on with your infrastructure. So when we're talking about infrastructure as code, obviously a lot of value there, as well as being able to manage any infrastructure. So we're not just talking specifically about, well, we can deploy an EC2 instance or we can deploy an S3 bucket. We're talking about really any infrastructure. So Terraform and our modular approach really allows us to be able to configure the infrastructure that we have, whether it's on-prem or whether it's in the cloud. And it doesn't have to be just those specific infrastructures like EC2 instances or maybe containers. We also understand that there may be things like DNS we have to configure or specific infrastructure pieces as far as logging. Maybe we're going to do some configurations of our secrets management engine. So it's really all encompassing. The idea is to be able to touch as many pieces of infrastructure and get all that into code so that we have a very robust way of managing our infrastructure. Now, if you've seen Terraform before, you've used it before, you know that it works in a two-phased approach, plan and apply. So if you look at that from a standardization or a workflow perspective, what you see is the graphic down below, right? Where you have a practitioner, you write some infrastructure as code, you run a plan, then you run an apply. A plan is that dry run, and apply is actually where we're going to make those changes, and out comes our infrastructure. So it makes it very easy to be able to replicate this type of workflow. Now, I talked a little bit about, obviously being able to track your changes in your infrastructure and being able to roll forward and roll back with code that makes it very easy. So if we're using something like GitHub, which everybody will need a GitHub account in order to be able to complete this, we have the ability to not only commit our code, but we can do things like create PRs so that others can review and require reviews. And we can do checks, syntax checks and code checks and normal linting that we would do in our normal applications. We can actually do that in our infrastructure as code as well. And that really is a collaborative process. So along with tracking our infrastructure, we're also collaborating with others so that way we're not implementing changes that would affect our infrastructure in a negative way, as well as maybe some different ideas of, hey, have we thought about doing it this way or have we thought about doing it that way? So that really is the core for what Terraform Cloud really unlocks, is this ability to be able to take infrastructure as code and kind of take it to the next level. Collaborative, governance, management, all the enterprise features that we need in order to be able to take this to production. So let's go ahead and get fired up and start doing some work. So we're going to sign up for Terraform Cloud. So quick overview, Terraform Cloud is a managed service that we provide. It's available to everyone. You'll be able to go get signed up. So when we look at that workflow, what we see is it looks a little bit different than our traditional workflow, but ultimately it's the same. It still works on that plan and apply, but we actually have some abilities that we didn't have in kind of that open source type of workflow, where we can start to do our infrastructure as code, but then we can include things like private modules. If you're familiar with modules of being able to reuse code, we can actually use our private module registry to be able to host those. And if we have folks who aren't Terraform folks, maybe they're not versed in writing Terraform, they can actually pull from that module registry and be able to actually implement directly. We're going to do state file management directly inside of Terraform Cloud, so we don't have to worry about any kind of secondary areas that we have to set up to share our state. We're actually going to keep that state file inside of Terraform Cloud. It's going to be completely encrypted and controlled, as well as being able to do RBAC controls to allow people to maybe do a plan and apply, but we don't want them to see what's in that state file because it will have sensitive information. So maybe we have an ops group where we can't share that information due to operational constraints, but we still want them to be able to do maybe a plan and apply. We can still do that as well. An API and a UI. So you're going to see an actual UI when we go do the sign up. You'll actually be able to interact with Terraform Cloud from a UI if you choose, as well as an API. So if we're talking about automation, this is really the key to unlocking all of our automation needs as we have that API available. We're going to do all this via remote operations. So all this is going to happen inside of Terraform Cloud. We're going to reach out via the API, whether that's to AWS or maybe Kubernetes, and even on-prem. If we're talking about Terraform Cloud for Business, that's basically the enterprise tier. You actually have the ability to do what are called remote agents and actually put those behind your firewall, and those can actually execute on behalf of Terraform Cloud. So we can really reach out, manage any infrastructure, no matter where it lives. So let's talk a little bit about the VCS Driven Workflow. So like I said before, VCS is going to become kind of a key component when we start to collaborate with our code. So what we want to be able to do is we want to be able to write our configuration and then have something happen, right? If we just write our configuration and then nothing happens, it's really not all that useful. So with this in Terraform Cloud, we have this idea of workspaces and VCS tied together. So what we'll do is we'll write our configuration, right? We'll commit those to version control, right? We'll tie those to a specific workspace. We'll configure a couple variables, and then we'll run that plan and apply. And then from there, we have some choices we can make. We can actually have it so it automatically applies, or we can have it so that it requires an approval step. But ultimately, we're taking action on that code right from the time we commit it and it's approved. Let's go ahead and create our account. So if you go to app.terraform.io/signup/account, you'll be given a create account area. Essentially, you'll create a username, password, provide an email address, tick the two boxes and create account. Once you complete that creating account, it's going to kind of do a quick start, and we're actually going to be kind of going beyond that quick start. So we want to say start from scratch. It should look something like this. And that start from scratch area will just allow us to give kind of a blank slate so that we can keep working. From there, we'll have to create an organization, right? So you'll create a new organization. Now, organizations, when we're talking about Terraform Cloud, generally what folks can do is they'll start with a single organization. Maybe they'll span out. Maybe you have different business units or different parts of your business that you want to separate completely. Organizations are a true delineation or boundary. So we won't be able to share modules between them, right? We won't be able to do some things, but really what that does is it gives us separation. So if we have things like RBAC controls that are going to be separate for different business units, we'll be able to do it from there. So we'll go ahead and give ourselves an organization name. We'll do an email address, and we'll hit create organization. And then once we do that, we'll move on to creating a workspace. So I'm going to go ahead and we'll just wait a couple of minutes here. If you're done, just write done in chat, and we'll continue on. All right, so hopefully everybody is progressing forward, right? We're creating that Terraform Cloud account, going through that registration process, going to app.terraform.io, and making sure that we have our account set up. We're creating our organization, and shall we move on? Let's go ahead and move on. So I talked a little bit about workspaces, and we'll kind of just give a little bit more information. So when we take our workspaces, what we're going to do is we're going to segment our infrastructure into manageable chunks. That's really what workspaces are designed to do, is to take things like a big monolithic infrastructure. Sometimes we say, hey, you know what? I'm going to manage my infrastructure. And what I want to do is I actually want to kind of segment that down based on maybe specific application teams or application types. Maybe even I have specific teams for operating systems or specific workflows around, organization as far as a storage team and a network team that I want to be able to segment. So workspaces really allow us to create those segmentations, as well as being able to do things like RBAC control, so we give the appropriate teams the appropriate access. So what we're going to do in this specific work area is we're actually going to create a workspace, and you're going to need a GitHub account for this. So if you don't have a GitHub account, you can go ahead and go sign up for one now. And we're going to take a repository that already has some existing code in it, and we're going to kind of work with that. So like I said, you have to have your AWS account set up, and you have to have a GitHub account. Now, again, this is a self-paced workshop. You can complete this at any time. So if you're a little bit behind, that's perfectly fine. Otherwise, we'll keep moving on. So the first thing we want to do is we want to fork a GitHub repository that has the code in it that we want to use for this example. So if you go to github.com, this specific repository here, what you'll be presented with is the normal GitHub screen. And we want to make sure we choose fork. And what this will do is this will actually fork this code into your own account, so that way you can work with it, you can manipulate it, you can do really whatever you'd like to do with it. So we'll go ahead and choose fork there. Now, once you have that fork created, what I'd like you to do is just review a few of the files, right? So you're going to have a main.tf, you're going to have variables.tf, your outputs, and versions. And really what it comes down to is I just want you to kind of look and see what we're doing. Again, HCL makes this incredibly human readable, so it should be very easy to kind of see the code that we have and what's going on. So I would highly recommend just kind of looking through there and just kind of seeing what's going on from there. Then what we're going to do is, after we have that forked and we've got that created and we've kind of reviewed our code, what we'd like to do is we'd like to actually connect this to a workspace. Again, this is a VCS Driven Workflow, so we're going to create this workspace inside of Terraform Cloud. So we'll go to our Terraform Cloud tab, and we'll choose this new workspace. And what's going to happen is it's going to take us to a screen that allows us to connect directly to VCS. So there's actually a choice here where you're going to choose a VCS Driven Workflow. Once you choose that, it's going to drop down and say, hey, what VCS do you want to connect to? In this case, we're going to say GitHub, and we'll do github.com custom, and it's going to provide you with an authorization. If you're a member of an organization, I would highly recommend that you fork this to just your personal repositories and not your organizational repositories, because in many cases, if you have an organization inside of GitHub, it would require additional approvals, and it may take longer for you to be able to gain those approvals, but you should be able to put this directly into your personal GitHub account. You'll choose to authorize HashiCorp in order to be able to connect that workflow. And like I said, in this case, you can kind of see where there's a specific organization that says configure, but you can choose the HashiCorp demo app. That would be the specific user. Again, I would go with my specific user, not my organization. Unless you're the admin, that would obviously be your choice. Then what we'll do is we'll create that new workspace choosing this repository. So if you've got a large group of repositories, once we got it connected, it'll actually bring that, it'll be in a small window there. It'll have all the repositories that are connected to the account that you chose. You can just type in TFC because that's the way this one starts. And what will happen is it'll actually bring up that guide. You can just click on that guide right there, and it'll actually create that workspace, right? You can choose to give it a name based on that VCS. In this example, we use TFC guide example. You can give it an additional description if you want to put maybe just a test run or test account, or whatever you want to put in there for your own personal notes. And once you complete that, what you should see is configuration uploaded successfully. And you're going to be presented with this overview, run, states, variables, and settings. But this is kind of the view that you're going to see. And that means that you have your VCS configured and that it's tied to this workspace. Now, it's not actually going to do any work right now because we haven't configured anything additional, but we're really just getting everything connected. One thing to note as well is when we're connecting with GitHub to the specific repository, if you submit a PR, what you'll actually see is Terraform will automatically include some basic testing. We call them speculative plans. These speculative plans run every time you have a PR. So kind of talking about that scaling workflow, if we're in a PR type of scenario where we're working with production resources, or maybe even QA resources, we have this ability to be able to kind of inject Terraform right into that workflow without you having to do any additional items. So that's really nice and really starts to build on that scalability and that collaboration. So let's go ahead and do that. Like I said, we'll start at the top here. We're on the creating a workspace, and let's just work through that. So I'll give everybody about 5 minutes, and if you can just put done in the chat, if you're done, and if we get a lot of folks that are already done, then I'll just move on. Otherwise, we'll just take the full 5 minutes, and we'll carry on. All right, just checking in to see how everybody's doing. Haven't seen anybody done in the chat, and I know this can be kind of the tricky part because we're connecting Terraform Cloud to GitHub, so we're connecting two different technologies together. So we want to make sure we get all the bugs worked out there. You said you'll create a workspace, you choose a version control workflow, and then you'll choose GitHub as your VCS provider. I normally choose GitHub Custom. It'll ask you for an authentication dialog. It should pop up. That window should pop up and say allow access. When you allow that access, then you should get a list of your repositories that are available to you. Do we need some more time, or shall we press on? And like I said, if we're still working through some of the challenges here, that's okay. You can complete this at any time. There's no time frame based on this. But if you'd like me to press on, just say that in the chat. Otherwise, we can continue to wait and continue to answer any questions. Just to make sure we're all on the same page and make sure that everybody kind of is seeing the same thing, I'm going to go ahead and change my screen share here to my Terraform Cloud screen. So you'll notice I haven't created a workspace yet. In this case, I would choose a version control workflow, right? So this is important. With Terraform Cloud, we actually have a couple different ways that we can drive a workflow. For the purposes of this workshop, we want to make sure we're choosing a version control workflow. But ultimately, you have a couple different options there. So if you want to use things like a CLI, you can. If you're very familiar with the CLI and maybe you want to interact with it that way, you can. But you can also do an API. In this case, we'll choose a version control workflow. Then I'll choose GitHub. Now, one of the questions that we had, which was interesting, is how do I do this? How do I bring in another repo other than TFC, maybe this example repo? You could actually do this here. Obviously, you can see all of my different repos, and I could choose really any of them and tie them to a specific workspace. So if you want to do this to maybe another repo, or you want to write some different code, you can do that and make that available. So you would just choose, in this case, I want to go ahead and do TFC.
Mike, it's Jim here. Can you maybe zoom up your screen a little bit? The quality's a little downgraded. Do one more. Go one more. You got white space. You can do it.
All right, we'll go one more. How's that look? Better?
I think so, yes.
Okay. All right. So, like I said, in the filter, I just put TFC. I go ahead and choose that. And like I said, if you're using in the future, if you want to do another repo, you can just choose a different repo. In this case, I would just call it TFC Guide Example, which is perfectly fine by me. We can name this anything we would like. For the description, I'm not really going to put a description in here. And then I'll just hit Create Workspace. What will happen is once I have that completed, you'll see the success, and it should be ready to go. It does look a little bit different than what we have in the slides, only because we've actually updated this. So it actually takes a minute to pop up, but you actually get that additional dialogue. So just be aware of that. From here, obviously, this is the normal screen we're used to. Now, if for some reason you did not get the dialog box You did not get the ability to say, you know what, I want this dialog box. I'm gonna have to make this just a bit smaller so I can see those different things. You can go into settings and providers, and you can actually add a provider here. So if you want to choose a provider, you can do that here, and it'll actually walk you through this process. So if for some reason you were not able to get that dialog box, and I've seen that from time to time where GitHub, for whatever reason, won't authenticate, or if you skip that, if you just close that window, you'll have to go up and set it up manually here. It does walk you through, Terraform does walk you through how to do that. So just be aware that that's a possibility as well if you choose. So hopefully everybody is able to get that fired up. Just going to move on to actually doing some deployments here. So we'll go down to deploying infrastructure, right? So again, when we start talking specifically about deploying infrastructure, that two-phased approach is still going to apply in Terraform Cloud. We know we're using HCL, so it's very human readable, very easy to document our code for us to understand what infrastructure we have deployed and to be able to change that infrastructure, right? And that's really what we want to do. We also want to store that state securely, so we'll do that inside of Terraform Cloud. And like I said, we can actually create role-based access controls to really provide granular access so we can allow folks to run plans and applies, but they don't necessarily have the ability to see what's inside that state file, because we do know that that state file will have sensitive information in it. So if we don't want to share that information, we can do that. We can also start creating things like variables and secure variables, and we'll talk about that here in just a minute. So that's kind of where we're at today. And we'll go into creating some infrastructure. So from Terraform Cloud, what we're going to do is we're going to start off by, and I mentioned variables before, we're going to go ahead and create some variables so that we're able to do some connectivity. When we want to do our provisioning, we have to be able to authenticate in many cases, right? Whether we're talking about AWS or even VMware or Kubernetes, we're going to have to be able to do some authentication, some authorization to allow Terraform to do those things, as well as being able to define our variables like we used to do in our code. We can actually define those here, so we can make them a little more accessible and available via the UI. So we're going to configure some Terraform variables in this part, right? And what you're going to notice is we're going to create a couple of different variables. We're going to create an instance type and an instance name, right? And we're not going to mark those as sensitive, right? And I'll actually show this part. So that way everybody can kind of see what we're adding. But ultimately, we're not going to make those mark those as sensitive because they're not really sensitive information. What's important to know is sensitive variables actually hide the information. So once you put that information in, it'll never be able to be extracted by anything other than Terraform. No human will ever be able to interact with it as far as seeing that. They can overwrite that. So if they have access to those variables, they can overwrite those if they're marked as sensitive, but they cannot see the values. And this is another area where self-service is very, very important. We need to be able to share sensitive information without exposing that sensitive information to folks who maybe aren't supposed to have that in like a least privilege type of access model. So once we add those variables, we'll go ahead and find our AWS credentials, right? So this is from our AWS credentials before, right? We'll have an access key and a secret key, just like we're used to working with AWS. We're going to go ahead and locate those. If you download the CSV, it should be in your CSV. Otherwise, you're able to log in and go view that from your AWS account. And then what we're going to do is we're going to choose an environment variable. So we're actually going to set up our environment variables. So when we're creating our environment, when we're creating variables, we have the choice of using Terraform variables or environment variables. And really what this comes down to is when Terraform Cloud spins up a runner specifically for your job, it will configure the Terraform variables and the environment variables that are required for that provider, in this case, AWS, so that it knows how to connect to AWS. It knows where the API endpoint is, but it's going to need that access key and that secret key in order to be able to interact with it in a secure manner. So in those cases, we do want to use sensitive variables, right? We definitely want to make sure that we're protecting those things. So we'll go through and create those, and then we'll just run a quick plan. So in this case, like I said, that two-phased approach, you're going to go ahead and you're going to go over to Actions and say Start New Plan. Now, you have to have all those variables in there. If you don't have the variables, it's not going to work. So we'll start that new plan once we have those variables set. And then what you're going to see is you're going to see this plan is going to finish. It's going to give you a list, just like you're used to with Terraform. If you're used to using Terraform open source, it gives you a similar output. In this case, we're showing kind of the verbose output. You actually can actually view this in a structured output as well. That's kind of the default, but you can actually change it if you want to have the more verbose, kind of the traditional look. But really, what this is telling us is I'm going to add some things, right? There isn't anything in this that the Terraform is managing from these infrastructure resources, so it should give us plus keys on all of those. If you're familiar with Terraform, you got plus keys, you've got kind of the orange tilde that's talking about changes, and you got minuses, red minuses for deletion. So as we're interacting with Terraform, it's important to kind of keep track of those. That really is something that's unique to Terraform, is being able to see what's going to happen long before you make any changes, right? So it's very powerful for us to write our code, to have our code reviewed, right? To run a plan, so that way we've got multiple areas and multiple steps where we're making sure our code is correct, that's going to do what we want it to do before we actually make those changes. And then we'll go ahead and apply those changes. Now, very important to note here, this is where Terraform is actually going to reach out to your AWS account, and it's going to make some changes. It's going to add some infrastructure. In this case, we saw what those infrastructure pieces were in a plan. Right? In this case, it's showing the structured output. We had the more verbose output, and it's saying, hey, you know what? I'm going to go ahead and add this very simple EC2 instance. It's running Ubuntu, and it showed it created it. It gave you the ID, some other information. You can actually kind of drill down into this and kind of see what's going on. But ultimately, that's actually where we're going to make those specific changes. Now, another really cool thing is in the Overview tab. Now that we've got everything connected and we've ran a plan, what we're doing is Terraform Cloud is actually reaching out to GitHub, and it's looking over the code that you have and compiling that all together. We also know that if there's a README, that we're going to provide some additional information as far as on the overview screen of kind of providing you the overview of what's going on with your repo, if you've got anything in the README, as well as what resources we are using. And so we're going to be able to, in very short order, be able to see kind of what the resources are that we're working with and what's available to us. If we're using something that's very complex or very large, we can actually very quickly, without having to go review the code individually, we can see what those resources are and then how I can interact with them. And then finally, the outputs area, right? Outputs, just like we're used to with Terraform, we have outputs, but very quickly and easily we can actually see those directly from the UI. So we actually don't have to do anything from the command line in this case. We can actually see these outputs, interact with them if we choose. Obviously, we can copy them, and if we need to use them somewhere else, we can do that as well. Another point to note, if you're not used to using workspaces with Terraform, if we put things in outputs, we can actually read them from other workspaces. So a workspace is not alone. It doesn't have to live alone. It can actually interact with other workspaces. A simple example that I can give would be something like maybe you have a security team or a network team that is providing your network and your security information. And you're going to need that for your instance, right? I have to be able to connect to a network. And in doing that, that availability, I can actually read from the outputs of maybe the security team putting that out there in an output, and I can actually read from that and use that in my code. That's a little bit more of a kind of an intermediate use case. It's kind of getting started in kind of a beginner use case, but there's plenty of documentation out there on how to do that. So if you'd like to learn a little bit about that, you can do that as well. And then what we'll do is we'll actually verify via the AWS Web Console that we have that running and everything is good. So this is our creating infrastructure, right? Where we defined our workspace, we get everything connected, right? We create some variables. We ran a plan to make sure it's going to do what we want it to do. And then we ran that apply to make sure that it actually applies. And we can verify all that via the AWS Web Console. So let's go ahead and do that now. And then again, if you have any questions, feel free, you can put those in the chat in the Q&A session. And we'll be glad to answer those. Let's go ahead and let's take 10 minutes for this one, because this one may take a minute. as you're starting to learn to navigate. And what I'd like to do as well is just kind of show you around, just so that we're all on the same page. I'll kind of show you around the, let's go here, connect. There, we got that there, right? So if we're inside of our workspace, kind of where we got everything connected, there's a couple of quick informations, right? So it knows there's a README here. It knows that the execution mode is remote, right? So some initial information here. I don't have any tags or run triggers. We're going to go over to variables. When we want to define our variables, we'll choose add variable, right? And this is where we're going to choose environment variable or Terraform variable. So when we're adding the instance size and we're adding the descriptions or whatever variables we want to do that are specific to our Terraform code, not the provider, we'll choose a Terraform variable. But when we want to do things like our access key and secret key, we're actually going to choose that environment variable area. Again, you'll notice that there is sensitive information in some of these, right? So we may, like on our access key and our secret key, we'll actually want to check this sensitive area. You'll notice it says write only. Once we write that information, it will be visible for us until we save it, and then it'll never be visible by a human again. So that should kind of get you up and running. Let's go ahead and take our time and let's get this done. I'm gonna give 10 minutes to kind of, and feel free to kind of poke around here if you start to look at states and kind of get used to this UI, because if you're using open source, this will be new to you, and that's okay. Let's go ahead and take a look around and just kind of poke around, but let's go ahead and get those variables created based on the workshop, and we'll go from there. Like I said, let's take 10 minutes and we'll go from there. So hopefully everybody was able to get the infrastructure created. Working through our workspace, we're adding some variables, we're doing some configuration of our workspace, really kind of interacting with Terraform in a meaningful way. So we've created some infrastructure, and while creating infrastructure is great, we have to be able to maintain that infrastructure over time. Being able to maintain that infrastructure is really, really important, right? So day zero is fine, we can create infrastructure. We have to also be able to update it. Now, Terraform is a stateful application, so we keep track of everything that Terraform provisions for us. So as we're creating instances, we're creating containers, whatever we're doing with our infrastructure, we're going to keep track of that in our state file. And beyond that, as we start to make changes, Terraform will actually take a look at the code that we're submitting for a change, and then compare that to what it knows about, and then check with whatever the provider is, in this case, AWS, and see where those differences are. And depending on where those differences are will depend on the activity or the action that it takes. So ultimately, what this does is it allows us to reconcile our infrastructure so it's consistent with our code and what's actually out in AWS. This is really, really handy as we start to go forward, right? Because deploying is the first step, maintaining is the second step. So we're going to kind of go through that and kind of go through that change process. So like I said, if you had some time to kind of poke around and take a look around at Terraform Cloud, hopefully you're able to kind of look through and see what some of the options are available. I won't cover all of them, but just know that they're there. When you have your run and it shows your run is applied, so we're good to go there, right? It's the latest run. And like I said, we have those runs. You can, and one of the unique things with Terraform Cloud and Terraform Enterprise is that we can actually see a revision of every state change that happens. Now, this is quite a bit different if you're coming from the open source world. What you know is that you can see your state, but you can't really see, there's no revisions of that, right? So being able to go back and see what code changed is possible, but being able to go back and see what state is available can be very difficult, if not impossible, depending on how you're managing your state. So with Terraform Cloud, we get this unique ability to not only see what the code changes are from the GitHub side, right, to see what applies have happened, right, if anybody's made a change, then we can actually reconcile all that inside of state. And where this is really, really handy is when you leave the office on Friday and everything is great, but you come in on Monday and something's broke, and what's the first question everybody always asks? What changed? What changed? And that is a great question to ask, and we can actually use Terraform to help us really make that process very quick and straightforward. Did anybody make any changes in Terraform? Now, somebody could have logged onto the machine and maybe made a change in the operating system, but ultimately, what we're talking about is what infrastructure changes have happened. Are there any infrastructure changes that we need to be aware of or that maybe somebody made that had an adverse effect? So a lot of different use cases here where you could benefit from knowing that. So having that run information, that state information, obviously being able to have those variables secure and insecure, right? We can actually lock workspaces so that they can't make a change. So if we have a really sensitive type of workload that we deploy once and maybe we don't want any changes to be made outside of a specific window, we can actually lock those so that even if somebody does have access to them, they won't be able to make any changes to them. We can control how, if we want to allow deletions, and if we do, we actually have to enable that. And we'll actually do this in the workshop as well. So a lot of different configuration options that we have to make sure that we are able to meet our governance and our compliance requirements, as well as being able to share this in self-service, but doing it safely. And really so that we can be confident with everything that's going into our environments, the changes we're making, and how we're making those changes. So what we want to do is we actually want to edit one of our variables. Right? So we'll go ahead and edit one of our variables section, and we'll do the instance name. And we're going to change that from provisioned by Terraform to updated by Terraform. And then we'll just click that save button. And then we'll do another plan, and we'll see what changed. Right? Just like I said before, this two-phased approach gives us a very unique ability to be able to look at our code changes from the GitHub side, but also to be able to see what happens from the infrastructure side before we ever apply it. And what you'll notice here in the more verbose output is you're actually going to see those little tildes, and it's going to show you what changed, right? So in this case, the name provisioned by Terraform was changed to updated by Terraform. Perfect. That's exactly what we wanted, right? Now, in the event where this is making a change to something that we didn't want to change, we can obviously not apply this. We can just say, cancel this, don't run it, and we can go back and make the appropriate code changes to actually get the results that we're looking for. So the good news is when we're doing these plans, it's not the final step. You don't have to continue. You can always cancel those runs away, as well. So just important, very flexible in that regard. So I talked a little bit about speculative plans before, but this is really when we start to integrate with VCS. We're using things like a PR. We're using specific testing requirements. We can Terraform will actually include those checks in our PR, so that way we can make sure everything is the way we want it, and that the syntax actually checks out. So once we make those changes, like I said, we do that plan. It's just very important that we're watching those plans, and when we do the apply, that we're applying those settings, that we're keeping an eye on everything that's happening along the way. You can also change, this is just talking about speculative plans, but you can actually go in and turn those on or off. So let's say that you already have a testing regimen and you don't want to introduce this, you can actually turn it off. In fact, if you go back to when I was talking about if you weren't able to get that pop-up dialog for GitHub, and you can go into those settings and choose the provider and choose the VCS provider, you can actually do it there. It's in that same spot. So it's up in the settings and then the provider, and you'll actually choose the VCS provider that you're using, in this case, GitHub, and you can turn those on or off. Really, really handy. So we'll go ahead and edit our configuration. In this case, what we're going to do is, like, this kind of goes towards that idea of updating and changing those configurations. So we'll just go ahead and update. We'll change the base repo so that it has your fork of the repo. And what you're going to see is you're actually going to see those speculative plans in work. We'll actually run that plan. So you'll see the distribution change. Then we have the ability to do that merging of pull request inside of GitHub. We'll actually merge that pull request. So we'll create that PR. We'll merge that pull request. And what we're going to see is in the runs tab, you're actually going to see that it's going to automatically start that plan. In this case, it's doing cost estimation as well. And we have the ability to choose whether we want to apply this change or not. And this is where the needs confirmation. And what's important as well to note here is that you can have it automatically apply. So if we say, our process is that we have a GitHub repository that somebody submits a PR like we're going to be doing right now, right? And we review that PR. So we have other people looking at that PR, not just one person. Obviously, in this example, it's just going to be one, but in a broader context, we would definitely have more than one person reviewing and making sure that code is good, that passed the Terraform checks. Maybe I want to automatically apply that, which means when Terraform sees the change, right, once we merge that into whatever branch we're tracking with Terraform, it will actually go out and make that change automatically. So you don't have to do it this way. This is where almost everyone will start, because you want to make sure that your plan is correct. You want to make sure that everything looks the way you want it, and kind of getting used to the automation. The only thing you have to do is choose confirm and apply, and it will actually make those changes for you. So just go ahead and run that confirm and apply. So like I said, we've got our VCS. We're going to make a change. We're going to do a PR, and we're going to look at that PR. We're going to submit that PR, merge that in, and then Terraform's going to pick that change up. It's going to basically run that plan for you, and then wait for your confirmation for you to do that confirm and apply. So let's go ahead and let's take another. We'll do 10 minutes for this one. I think 10 minutes would be good, because as you're kind of navigating, if you're not familiar with GitHub, it can be if you're using the UI, or if you want to use your normal VCS, you can do that. Or I'm sorry, your IDE, you can do that as well. But let's go ahead and let's do that PR process and bring everything together. Hopefully, everybody was able to kind of go into Terraform Cloud, make our changes instead of GitHub, update that infrastructure so that we can see what that looks like going forward, and do that confirm and apply, and just kind of see that whole workflow process going through. And again, if you're following along and maybe you're a little bit behind, that's perfectly fine. Self-paced, so just kind of making sure everybody's familiar with the content. So had some great questions, some great conversation. There might be a need for a deeper dive into some of these questions, because we can answer some of them and kind of show those ways. I don't really have time to go into those today, but I think that there definitely would be grounds for some more deep dive conversations. So moving on, we're going to talk a little bit about Sentinel and policy and governance. And this actually goes to one of the questions that was asked, and one of the points that I was making. So with Terraform, obviously we're defining all of our infrastructure as code as much as we can. We want to put as much as we can in that infrastructure as code scenario for all the reasons that we discussed before. And a lot of times when we're doing this, what you see is this scenario where you have infrastructure as code, but then you have our friends in security, or maybe security is a part of that infrastructure team. But the security process traditionally is not always included in that infrastructure as code process. Now, there's a lot of reasons for that, right? Compliance and governance generally, as I've seen it, will be in the form of maybe a Word document or a PDF, maybe even a spreadsheet. And it really is a checklist of items. It's a list of things that we have to make sure are done or not done based on our compliance and security standards. And so as we're looking at those things, we have to find a way to make them actionable, right? So if I'm able to provision infrastructure really, really quickly and change and update that infrastructure really, really quickly, we have to be able to include our security and really our security footprint and our security controls, and make sure that we're minimizing the ability for us to misconfigure or configure outside of a compliance standard. And we actually do this with what's called Sentinel. So Sentinel is a policy as code engine, right? It's policy as code framework, just like Terraform is an infrastructure as code framework. Sentinel works in the same idea or the same vein. So when we're looking at Sentinel, what we're going to do is we're going to have our code that we write, and then we're going to have our friends in security who may or may not be familiar with Sentinel, but ultimately they are going to give give us some, maybe it's like I said, a Word document, or maybe it's a spreadsheet, and they're going to give this information to us. And what's going to happen is we're going to look at this, and if we're doing one instance, that's really easier. One very small piece of infrastructure, I can have somebody manually go through and try to make sure all those checks and balances are done. But ultimately, if I'm doing 1,000 or 5,000 or 10,000 at a time, that becomes unmanageable really, really fast. So we're going to define that specific policy and governance inside of Sentinel. And what this does is this actually kind of changes the way we look at Terraform and our ability to be able to do things inside of a lifecycle environment. So when we talk about policy, let's kind of talk about how we go about doing this. So like I said, all policy is going to be defined as code. We want to be able to do that so that we can get that agility like we have with infrastructure as code, but we want to make sure we're including all of our security and compliance directives, right? It's going to happen inside of those life cycles. And in fact, since we're talking about Sentinel specifically, I can choose which policies happen on which workspaces. So in the example where I have multiple compliance and governance standards that I need to apply for different things, I can actually segment that infrastructure into different workspaces and then apply the specific security and governance requirements for those specific workspaces. So a lot of flexibility here to be able to define what our security and policy guidance is and apply those before anything goes out the door. Now, with Terraform, we know we have that two-phase approach, plan and apply. What we're going to see is we're going to see plan, policy check, and apply when we're talking about Sentinel. And the reason why this is so very important is because when we run a plan gives us an output of everything that's going to change. And with Sentinel, we can actually evaluate all of those changes and then see if they meet or break our compliance standards that we define inside of Sentinel. And the reason why that's important is because nothing's going to go out the door that's misconfigured or that's against our security policy. So this becomes very powerful in the idea of saying, I never want to have anything, even if it's for 5 minutes, that's sitting in a environment somewhere that's misconfigured. So Sentinel gives us the ability to make sure that that absolutely happens, and it makes it part of the process of our deployments. So similar to what we did before, we actually have a repo that's specific to Sentinel, and will give us some code examples. So we'll be able to actually take those, and just like we did before, we're going to fork those over. And once we do that, just take a look around, just like we did with the other ones. We'll take a look around at the files, kind of see what's defined in there, see what's going on, kind of get familiar with it. Sentinel is a little bit different than what you're seeing in traditional Terraform because it's based on policy. So we're going to define a policy. We're going to define some actions. From a high level, it's very similar, but as we start to look at the syntax, it's just a touch different. Another thing to notice is that we have what are called policy sets. We start grouping things together because most likely when we define our policies, we're going to have a set of compliance or a set of policy standards that we need in order to be able to ensure that what we're configuring is correct. So we have these policy sets. We also have the ability to be able to specify what level of compliance is necessary for a specific policy. So what I can do is I can say, hey, it's advisory. So if I break a compliance standard or a security standard, I can have Terraform just notify me, say, hey, you know what, this breaks policy, but I'm going to continue to run anyway. I see that being really valuable in dev environments where we're testing something where maybe we're going to ask for a security exception. So in that scenario, maybe advisory would be just fine. We also have soft mandatory. Essentially what happens is the run actually stops. So it'll do a plan, a policy check, and if it finds that it's not in compliance, it actually stop and require one of the Terraform admins to approve, or whoever you deem. You can actually use RBAC controls to deem who's allowed to admit that to go through. But ultimately, it can be overridden and continue to run. So in scenarios like maybe it's our QA environment where we haven't got those exceptions in place yet, we still have the ability to be able to say, you know what, I don't have those in place yet, but we're okay in QA. We're not going to production yet. And then almost always in production, we go with hard mandatory. And what this means is if we break our policy in any way, we are going to notify whoever's running that what that break is, and then we're going to stop. We're not going to allow you to continue. Because again, having something misconfigured in any environment is no good, especially when we start talking about production resources. We have to make sure that we're meeting those compliance standards. So kind of look through, you're going to see, like I said, if you're exploring the policy and looking through the different files, you'll see those Sentinel files. Kind of take a look through them, just kind of breeze through them. You'll see that there's a lot of different information that's available. If you start looking at the documentation for Sentinel, there's a lot you can do with it. So this is going to be a very brief overview of that. Before we can start doing Sentinel, though, I'm going to have to kind of talk a little bit about how we're going to do this. So when we get done here, I'm actually going to circle back and share my screen and show you how you can actually get a Terraform teams and governance trial for 30 days so that you can actually use Sentinel. So we'll cover that here in just a minute. So we'll go into our settings, go down to our policy sets. We'll connect a new policy set. And just like we have with workspaces, we can configure those. We can point those towards a specific VCS repo. We'll have the ability to be able to actually define those, just like we did with our workspaces. You'll see that animated picture here where you can choose that example and it'll actually enable that and make that policy set available for you, right? Once you choose that policy set, you can click in on that. You can see what's going on with it. You can make some choices of what workspaces you want to define and how you want that to execute. Right now, you'll notice this says all workspaces, but you can choose to do a specific workspace if you need to. And then we'll do another run. And what we're going to see is because we have now defined in a workspace that we have policy and governance using Sentinel, what you're going to see is that policy check. So plan and cost estimation is a part of that. It runs independently, but you can actually write policy based on cost. Policy check, and then below here would be the apply. So this is really a pretty powerful step. And let me just show you how to get that trial started. So let me stop sharing my screen real quick. And I'll share my Terraform screen. All right. So if you go into your Terraform, you should see this black box that says free trial available. You can choose to upgrade, choose a trial plan, and start your free trial. When you do that, you will actually have policy sets that will be available to you and actually make the ability for you to do those. So you'll need to do that, and then you'll have to log out and log back in. And once you do that, you'll have policy sets available. So just to be aware, that's how that works. And we're going to go ahead and do 10 minutes here, and we'll make sure that everybody gets going. And if there's any questions, again, in the chat, we'll be here to answer any questions. All right, everyone. I actually was going to do 10 minutes, but I know we're running out of time, and I want to make sure that I covered the last part, which will be cost and kind of controlling those costs with policy, as well as making sure that everybody's familiar with the cleanup process. So if you don't want to leave these resources out there, which you may not, that we can actually do that cleanup. So let me go ahead and move through that so that we're all familiar with what the next steps are. Right? So I mentioned being able to control costs with policy. So Sentinel is really, really powerful when we start to talk about things like I've got governance or compliance standards, but also being able to control costs. So maybe I have a scenario where a development team is allowed to spin up maybe a GPU resource, but you don't want them to spin up multiples, or maybe we only want a run to be X amount of cost change. We can actually start defining those in our policies as well. So we have the ability to really kind of narrow down not only our compliance standards, but making costs a part of that compliance to make sure that we're not misconfiguring or people aren't going outside the bounds of what we want. And that really will be important when we start to talk about self-service. With self-service, we can't do self-service without some sort of guidance, without guardrails to be able to protect our organization as new folks start to come in and start to be empowered with the self-service idea. We want to make sure that they're doing it appropriately. So that being said, again, we're still going to need the same things. This is going to be really more of the same. You're going to fork a sample repository, right? And this will actually have cost controls in there. Configure it to be in a workspace. You can apply it to an existing workspace, or you can create a new workspace for that. We'll configure some variables. We'll do this policies, and this is really designed so if you want to run this later on, you can actually run this one by yourself, just self-contained. So it'll actually walk you through creating a workspace as well. So if you want to run this independently, sometimes there's a lot of information here, so maybe you'll want to come back. You can run these independently as well. Obviously, verify our costs using our policy. We'll create that policy set just like we did before. So it's just really more of the same as far as the workflow, right? We want to keep that consistent, but we're actually doing some new things, right? We're actually including some different costs. So we'll run our new plan. And what we'll see is we'll see the cost estimation will actually run. And because we're less than $100 a month, we're able to continue that. If you were to change that to $5 a month, obviously that would fail. It would kick that back. And depending on if you have that set to mandatory, like hard mandatory, or whether you have it set to advisory, depending on what actions Terraform Cloud will actually take. So same way you can delete those policy sets. Anytime you want to have a policy set you can define, you can also remove that policy set as well. And you have the ability to do a destruction and deletion of a workspace. So that kind of just takes us into that idea of cleanup, right? So just like you're familiar with doing a Terraform plan and apply, we include that policy check in between. We can also do a destroy. So there's some things that you have to do in order to be able to enable destroy. So we'll actually walk through that, and you can go through the settings, destruction and deletion, right? Which what you'll see here, which is really cool because one of the questions that I get commonly is, how do I make sure somebody doesn't accidentally run a destroy plan on something that we have in production? You can actually control that not only with the lock, but also not enabling destroy and deletion. So we'll go through, we'll queue a destroy plan, just like Terraform is. If you're used to using Terraform open source, when you queue a destroy plan, it works the same way. In this case, it makes you do some extra verification to make sure that you're doing what you want to do. And then ultimately, we'll destroy those infrastructure. It's going to look just like a normal apply. The only difference is, again, we'll have it in red. That red minus will show us that we destroyed it. And then we can obviously remove that IM user. We can delete the workspace if we want, or you can keep it there. And that will pretty much conclude everything that we did today. So we've got involved with Terraform. We've done some applies. We've done some destroy. We've kind of got a little bit of policy and some cost checks in there. So with that, I will leave you with this. You can go back and do this anytime. It's always available to you. There's no time box in that. And for that, I will turn it over to Cody. Thank you, everyone.
I'd like to remind our audience that the session was recorded. So if you would like to rewatch, to follow along, or try this out again, the recording should be sent to you within about 24 hours. So not much delay in getting this content back over to you. The recording will be emailed to you. You can also find it living on the DevOps website at devops.com/webinars, and it will be found in the on-demand section. So we do have 4 $25 Amazon gift cards to give away during today's workshop. Our first winner is Maria V. Our second winner is Garrett G. Our third winner is Avnish J. And our fourth and final winner is Anjani K. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. I would like to thank Mike for taking the time to be with us. Mike, do you have anything you want to let our audience know before we officially close out today?
No, I just want to thank everybody for joining in. The recording will be available. Obviously, that content is I know I've said that a couple of times, but I want to make sure it's not time box. You can rerun it at any time, and I would highly suggest doing so. So, take a couple weeks and then go back through it and make sure you're familiar with it, because I think it's very valuable.
Awesome. Thank you, Mike. And I would also like to extend some gratitude to some support staff we had. We had Mike Doheny from HashiCorp with us, who helped set up a lot of stuff, and we had some help from who was that? Welly from AWS jumped on with us, and Jim Sullivan from HashiCorp came on to answer some questions. So I do want to thank everyone involved with today's web workshop. And my final thanks, of course, goes to you, our very active audience. Thank you all so much for engaging with us today and for being part of this workshop. We hope to see you at a future Techstrong Learning webinar or workshop, but Otherwise, have a great rest of your day. And Mike, again, thank you.